Hello everybody and welcome to a new video. In this video we will cover measures of dispersion. Remember last week we talked about measures of central tendency and we calculated the mean for our data, the median and the mode. This week we will talk about measures of dispersion and we will determine the range of a variable from raw data. We will determine the standard deviation of a variable from raw data. We will determine the variance of a variable from raw data, and we will use the empirical rule to describe data that are bell-shaped and use Chebyshev's inequality to describe any data set. Let's compare two sets of data by looking at this example. To order food at McDonald's restaurant, one must choose from multiple lines, while at Wendy's restaurant, one enters a single line. The following data represents the wait time in minutes in line for a simple random sample of 30 customers at each restaurant during the lunch hour. For each sample, we want to answer the following. What was the mean wait time? And then we want to draw a histogram of each restaurant's wait time. And here's the raw data for both wait time at Wendy's and wait time at McDonald's. So here I have my raw data. I put the raw data in a spreadsheet and I'm about to calculate the mean wait time for Wendy's. So to do that, I'm going to do that in this cell. I will type equals and then average. And then I'm going to select all of my data and then press enter. The same way I'm going to calculate the mean for the wait time at McDonald's. So as you can notice here, we have the same mean. We will come back to this later to discuss the dispersion of our data or the spread of our data. As you can notice, the data is centered around this value, 1.39 from the mean for both sets of data. So that doesn't show us anything about those two sets of data. And here are the two histograms that represent both sets of data. This is the histogram for the wait time at Wendy's, and this is the wait time at McDonald's. And you can notice that the wait time at Wendy's is less spread, but the wait time at McDonald's, our data is kind of spread out a little bit more than the wait time at Wendy's. And we will discuss this deeply when we go into the concept of measuring the dispersion of the data. The first measure of dispersion is what we call the range. So how do we determine the range of a variable from raw data? The range, we will use the uppercase R to indicate the range. The range of a variable is the difference between the largest data value and the smallest data value. We discussed this when we started building our classes and building frequency tables for quantitative data before. The formula for the range is just the largest data value minus the smallest data value. And to calculate the range, let's say for these two sets of data, I'm going to calculate the range for the first set of data and calculate the range for the second set of data. And in this case, I'm not going to use the data analysis function. I will use the maximum amount and the minimum amount. So to calculate the maximum, I'm going to write maximum here. And to calculate the maximum amount for the first set of data, I will use the function max. And then highlight my data or select all of my data, enter. And to find the minimum, I will use the function minimum. And highlight all of my data or select all of my data and press enter. And then to find the range is just basically the maximum minus the minimum. So the range of the first set of data is 3.64. Let's compare to the range of the second one. And then the minimum for the second set of data. And then from here, I can find the range of my data. So the range of my data is basically the maximum minus the minimum. I know the value is 0 here, so there's no difference. And as you can see, the range of the second set of data is bigger than the range of the first set of data, which makes sense. The difference between the numbers in the first set of data is not huge, but if you look at the difference in time, in the waiting time at McDonald's, it varies a lot. Let's look at this example and try to find the range for the set of data given to us. The following data represents the travel time in minutes to work for all 7 employees of a startup web development company, and we want to find the range for this type of data. So we know that the range is the biggest value in our raw data minus the smallest value in our raw data. That is 43 minus 5, which is equal to 38. As you can notice here, this doesn't tell us a lot about the numbers in our raw data because it only uses 2 values, the minimum and maximum. So we will need another measure that is a little bit more precise and uses all sets of data in order to determine the spread of my data. So to do that, we will use something that we call the standard deviation of a variable. So how do we determine the standard deviation of a variable from raw data? We will go over the definition since that is the procedure to find it, and then I will introduce the 2 formulas which we are not going to use anyways, but it is a good idea to practice using those formulas to find the standard deviation. So the population standard deviation of a variable is the square root of the sum of the squared deviations about the population mean divided by the number of observations in the population. That is, it is the square root of the mean of the squared deviations about the population mean. The population standard deviation is symbolically represented by lowercase Greek sigma. And to determine the standard deviation from the definition, we can derive this formula. We find the variations of the observations about the mean and then square the values, add it up together, divide by the number of observations, and then finally take the square root of everything. A formula that is equivalent to the one on the previous slide is called the computational formula for determining the population standard deviation, and that is sigma is equal to the square root of the sum of all squared observations minus we add all of the observations up and then square them, divide them by the number of observations, and then we subtract that from the sum of the squared observations, divide that by the number of observations, and finally take the square root. And as I explained before, we will not use any of these formulas, but it is a good idea to practice on how to use that. So let's look at the previous example. We have this set of data. Let's try to calculate the population standard deviation for this data. So in the first column, we will have all of our observations. In the second column, we will calculate the mean. I will show you how to do that on Excel. We will find every observation minus the mean and put that in a column and then square that value, add everything up and add the last column up and then divide by the number of observations we have, which is 7, and take the square root. That will be approximately 11.36. So let's see how that is done in Excel. I put my raw data in the first column, and that represents all of my observations, xi. The second step is to find the mean for my raw data. So what I will do, I will go to this cell and type in average, and then select all of my data. And since I don't want this to move anywhere, I'm going to press F4 to lock everything and then enter. So it will calculate everything for me. In the next column, I'm going to calculate each observation minus the mean. So that is equal to the first cell xi minus the second cell, which is the mean. And then I'm going to click enter. This function here is going to autofill everything. So if you click here and then click on that, it will fill the table for you. By the way, I highlighted my data to create a table, and then I went to the Insert tab and clicked on the table to turn my data into a table. It's easier to work on that way. In the last column, I am going to square the deviations from the mean for the observations. So that will be this cell, and that is raised to the second power or squared, and that will calculate everything for me. In this cell, I'm going to write the total. In this cell, I will add up the last column together. So that is the sum of the entire column. And I got that number. The second step is to divide by the number of observations and then take the square root. So I'm going to do that in one step right here. I'm going to say I want to take the square root, so SQRT, of this number and divided by the number of observations, which is 7, and then click enter, and I will get that number. Now to round that number, I will go to the home page, and then I'm going to choose number from here, and that should round it for me. To use the computational formula, I'm going to repeat the process here, but in different steps. So hopefully you remember that the computational formula looks like this. The first step I'm going to do, I'm going to highlight my 2 columns, and then I'm going to turn that into a table. It's easier to do it that way. So it turned into a table. The next step I will do is to square each observation. So I'm going to click on the observation and raise it to the second power. To type in this caret sign, press shift and the number 6. And when you click enter, the table is going to be filled automatically. What I will need is the sum of all observations, and then I'm going to square it, and the sum of all squared observations. So I'll find the sum of all observations first. And then I'm going to find the sum of all squared observations. So I found the sum of observations and the sum of squared observations. That is the sum of all squared observations minus the sum of all observations. And then I'm going to square it divided by n, divide everything by n, and then find the square root. So let's do that. So the first step, I'm going to do this part, which is finding the sum of all observations squared divided by the number of observations. So here's the sum of all observations, and I'm going to raise it to the second power and then divide that by 7, which is the number of observations. I got that number. Then I'm going to calculate the sum of, I am going to calculate this part, the sum of the observation squared minus the amount that we just calculated, divide by 7. So to do that, I'm going to go equals the squared observations, the sum of all squared observations minus the amount that I calculated. And then I'm going to close the parentheses, open parentheses here, and then divide that by 7. So I get that amount. So far, I calculated what's inside the square root. The last step is to take the square root for the amount that I just calculated. So that is the square root of the last amount that I calculated. And sure enough, I will get the same number. And similar here, I'm going to go to this square and click on numbers to round it to 2 decimal numbers. Those steps are very hard to do and keep track of. So what we will do is we are going to actually calculate the standard deviation of raw data using Excel. To do that, you're going to use the function standard deviation. So it is stdev.population, since in this case we're calculating the standard deviation of the entire population. So you could choose your raw data from the first table or the second table. It doesn't matter, just don't mix up your numbers, and then click enter and you will get the same number. And again, you can go here and then click on numbers, and then that will round it to 2 decimal places. As you can see, this is just one-click calculation, and there is even another easier method to finding all of the descriptive statistics, the mean, median, range, and all of these descriptive statistics that we learned so far. We just calculated the population standard deviation, sigma, and now we are about to calculate the sample standard deviation, S, of a variable, which is the square root of the sum of squared deviations about the sample mean divided by n-1, where n is the sample size. As you notice, it's exactly the same formula, except for we divide by n-1, and we'll talk about that later. The notation is S instead of sigma. And that is the computational formula, and you guessed it. The only change here is we don't divide everything by the number of observations, but we divide by the number of observations minus 1. We call n-1 the degree of freedom because the first n-1 observations have freedom to be whatever values they wish, but the nth value, which is the last one, has no freedom. It must be whatever value forces the sum of the deviations about the mean to equal to 0. Let's look at an example to find the sample standard deviation. From the previous example of the 7 employees at a startup web development company, we had a simple random sample of those numbers, 5, 26, and 36. I explained how to find a simple random sample using the random function on Excel. So do that. Your answer is going to be different from this one, but this is how it is done. So if we do that, we will end up with a different standard deviation, and that is totally normal because we just chose a sample instead of the entire population. And the answer is going to be similar if we use the computational formula. The process is exactly the same, so I'm not going to go over that one more time, but I will show you how to find the sample standard deviation. And in this case, I'm not going to choose a random sample. I will just use 3 numbers that I choose from here, just to show you how to do the standard deviation function. So you're going to say standard deviation, but instead of choosing the first one for population, you're going to choose this one that says .s. That's for a sample. And then I'm going to choose those 3 values and then click enter. You will get a different number from the number that we chose before because those numbers, as you can see, the spread of those numbers is not huge. The difference between them is not that huge. And now to round this number, I just click here and then click numbers, and that should round it for me. So as you can notice, the sample standard deviation is different from the population standard deviation. Although most of the time we deal with samples instead of population, but it doesn't hurt to know both of them. Now let's go back to the example of the waiting time at Wendy's and McDonald's, and let's calculate the standard deviation for each one of these. Remember, we are dealing with a sample from Wendy's and a sample from McDonald's, so we are going to calculate the sample standard deviation for both. So let's do the standard deviation for the first set of data. And let's do this sample standard deviation for the second set of data. As you notice here, the standard deviation for Wendy's waiting time is less than the standard deviation for the waiting time at McDonald's. And if you notice from the data, that the waiting time at Wendy's is very close to one another. It's not that dispersed. But if you compare that with the waiting time at McDonald's, it is very dispersed. Some of them are 0, and some of them are as much as 4 minutes, almost 5 minutes. So that's a big difference between the time. This data is more uniform, and this data is a little bit dispersed. So that will tell us something about the distribution of our data.